So a little bit of a strange time. School is out. Haven't seen you guys in a while. You might be working on section 3.3. I just wanted to give you a little taste of this. So what we're supposed to do in this section is use synthetic division to divide x to the fifth plus x to the third minus 2 by x minus 1. Now I was going to relate this to long division. Let's flip this over real quick. X to the fifth plus x to the third minus 2 divided by x minus 1. Okay, in long division, you'd have something crazy like x to the fifth plus 0x to the fourth plus there's a 1x to the third plus 0x squared plus 0x minus 2 divided by x minus 1, and nobody would want to do this. But you say, how many times does this x go into x to the fifth? And you'd say x to the fourth times. So you put this above this term here, even though there's a 0 placeholder there. There's actually no x to the fourth in the dividend. X to the fourth times x to the fifth, and then minus x to the fourth, and we subtract. X to the fifth minus x to the fifth gone. 0 minus minus, that's 1x to the fourth. Bring down the 1x to the third. X goes into x to the fourth one time, x to the third. So we've got x to the third times x, that's x to the fourth. X to the third times negative 1, that's minus 1x to the third. And we subtract. This is old-fashioned division. So x to the fourth minus x to the fourth gone. 1x to the third minus 1x to the third. That's 2x to the third, actually. And there are no x to the second, so we bring down 0x to the second. X goes in x to the third, 2x to the third. How many times will x go into 2x to the third? You'd say 2x squared times. So 2x squared times x, 2x to the third, 2x squared times negative 1 minus 2x squared. Let's subtract. This goes away. 2x to the third minus 2x to the third gone. 0 minus minus. That becomes positive 2x squared plus 0x. Nasty. X goes into 2x squared. 2x times. 2x times x, 2x squared. 2x times negative 1 minus 2x. Now let's subtract. 2x squared minus 2x squared gone. 0 minus minus, that's positive 2x minus 2. So how many times will x go into 2x? We'll say plus 2. So 2 times 2x is 2x, and 2 times minus 1 is minus 2. Subtract, we get a remainder of 0. So when we divide this nastiness, you get x to the fourth plus x to the third plus 2x squared plus 2x plus 2. So x to the fourth plus x to the third plus 2x squared plus 2x plus 2 is going to be our answer. That's quite ugly, but let's use synthetic division and do it in a much easier fashion. So x to the fifth, we say there's a 1. There's no x to the fourth, we put a 0, and then x to the third, the coefficient out front of that would be a 1. You need placeholders for x to the second, x to the first, and then a negative 2. And we could divide by this x minus a. Luckily we have it in x minus a form, so we put a 1 here. We have the required form that we desire. Synthetic division works like this. Bring the first number down. 1 times 1 is 1. Add 1. 1 times 1 is 1. Add 2. 1 times 2 is 2. That's my dog. Add 2. 1 times 2 is 2. Add 2. 1 times 2 is 2. 0. So originally you had x to the fifth, and you divide by x. So we have x to the fourth plus x to the third plus 2x squared plus 2x plus 2. You compare to this and you say, wow, gravy. It's exactly the same. All right. Is negative 3 a 0 of this function? Show your work to prove your reasoning. If we did synthetic division and we get a remainder of 0, then it is. Or if we plug negative 3 into the function and get 0, it also is a 0. Let's do the synthetic division route. This says 3x to the third minus 7x squared minus 2x plus 5. And somebody says is negative 3 is 0. So you bring the 3 down. 3 times negative 3, negative 9. That's negative 16 when you add. Negative 3 times negative 16, positive 48. Add, you get 46. Negative 3 times 46, that's negative 120 plus 18, negative 138. What a delight. Negative 133 is our remainder. Does this equal 0? Does not. So, negative 3, not a 0. What's the other way you can do it? Is you stuff a negative 3 into your function. And we get to work on our mental math. Negative 3 to the third minus 7 times negative 3 squared minus 2 times negative 3 plus 5. Hopefully we're still in the frame here. Negative 3 to the third, everybody knows that that's negative 27. 3 times negative 27. We've got minus, negative 3 squared is positive 9 times 7, negative 63. Negative 2 times negative 3 plus 6 and plus 5. The family's watching the movie Clue in the other room. Hopefully you can't hear that. 3 times negative 27, negative 81. Minus 63 plus 6 plus 5. Negative 81. Let's see, that looks like negative 144. 8 and 6 is 4. Yeah, negative 144 plus 11. I'm going to go out on a limb and say negative 133. Not a 0. Glorious. So, given negative 5 is a 0, find the remaining zeros, determine the y-intercept and graph. So, this is an x to the third. And when you have an odd function, odd, it rises right and falls to the left. We learned this in a previous section. It says negative 5 is a 0, so we're going to do synthetic division. We say 1x to the third minus 1x squared minus 22 and 40. And we put a negative 5 out here. Bring the 1 down. Negative 5 times 1 is negative 5. Add negative 6. Negative 5 times negative 6, that's positive 30. 30 minus 22 is 8. Negative 5 times 8 is negative 40. Remainder 0, like we would hope. So we had x to the third, and when we divide, we decrease by 1 degree. X squared minus 6x plus 8 equals 0. To find the other zeros, the remaining zeros, you factor. So you say, oh, this is not very hard. We've got middle is negative and the end is positive, which means we have 2 negatives. What 2 numbers multiply to be 8 and add to be 6? Well, clearly 4 and 2. So my zeros are x equals 4. Oh, that's very nice. X minus 4 times x minus 2 equals 0. Okay, so your zeros are 4, 2. The original one was negative 5. We know this thing rises to the right. All the multiplicities are 1, meaning there's only one x equals 4, there's only one x equals 2, and there's only one x equals negative 5. So what that means is when you come to the point, you go through. Now, we don't really know how far down. We just know it goes through, but it also has to come to here. The only other thing they said is get the y-intercept. So we plug x equals 0 here. We got all these are zeros, and it's positive 40 for the y-intercept. So this thing goes all the way up to 40, which that's nowhere near 40, but you get the point. And then we come down. We go through something like this. Now, this is not a perfect graph. If you graphed it on Desmos or your graphing calculator, it would look a good deal different, but the critical points are the same. It rises to the right, falls to the left, and here are your zeros for certain. Thank you.